So we've been talking about the moist continental classes. These are north of the moist subtropical continental classes, and they involve less land-sea interaction and distribution and more extremes of heat and cold in the interior of the continent. When we are looking at, we looked at a humid continental hot summer, where that was Iowa and growing corn. And we looked at humid continental cool summer, and that was Catskills and Winnipeg, Canada. Now we're going to look at another type of moist continental climate, and that is the subpolar climate. We can find that up in Fairbanks, and that, is not going to have deciduous trees. That climate is going to have more of the evergreen trees up there. And again, you have little precipitation in this environment. It gets quite dry. This is north of the 60-degree latitude, so you're getting into those higher pressure areas where there's less, where there is less precipitation. When we look at the polar climates, which are class E, you even have variation in the polar climates. There is tundra versus frozen for the polar climates. And tundra can be quite beautiful. Look at this. This is in July and August in the Arctic areas, where you can have the bloom of the low-lying brush in that area. So these have year-round low temperatures. They're never going to get warm in these areas, but some areas can be more frozen than others. And it's ET, T is the tundra, and EF and F is for the frozen for the classes. This is a polar bear stranded out on an ice block. When we look at Barrow, Barrow, Alaska, which is just a few hundred miles north of Fairbanks, where we were looking at, there's a decided difference when we get into the polar climates. And there is a dramatic difference in temperature, but not much of a difference in the precipitation, because again, we're getting very dry here as we get toward the poles and toward that high pressure area. When we are looking at the next group, the Highlands group, which is so different, these Highlands groups can be in subtropical areas, they can be in polar areas as well, but they are so different with the Highlands because there's such a change over that vertical elevation. We have learned that there's a huge change in pressure over a vertical elevation. We talked about the fact that skyscrapers in New York City have such a dramatic change between the sidewalk and the top of the skyscraper in terms of pressure and in terms of temperature. And you're noticing that same effect when you're looking at the Highlands. And in fact, you get a decrease in temperature, as you know, with altitude and that expansional cooling. And you get a very big change in vegetation along the windward side of the mountainside, and then an even bigger change in vegetation on the leeward side, where you have a desert in effect. So these highland classes are so difficult to group that they are put into their own class as highlands. And you can see that on the map, where you see highlands come in wherever there's a mountain range. That's the end of the Koppen classifications. Now we're going to go in, since we've studied climate, now we're going to go in to study how climate is changing a bit. See you there.